Hi, this is Andrew McLaren. I want to talk about the typical challenge problem that you're going to see on like an AP chemistry test or a college chemistry test around rate laws. They typically follow this format. So I wanted to show you this one where you have like a data table. Because there's some easy ones where they give you a data table and some more challenging ones where the data is a little bit different. Um, it's not that hard, but to think through it just takes like a little bit more thought. So we'll go over how to do those so that you can solve k, or you can solve for rate laws using little k with those challenge problems, and that you can solve like all of these ones when you have a data table. So I've got two different rate law problems here. One of them is pretty easy to do. You can see that this one has a constant concentration between two different trials because we've got trials 1, 2, and 3. And then we also have in this situation, it's constant between 2 and 3. So when you have the two different concentrations constant between like trials 1 and 2 and 2 and 3, those are pretty easy. Those aren't too bad. When it gets tricky is when you have something like this where there's only one thing that's held constant between the trials and the other one is not held constant. It is still doable, but the math is a little bit trickier, and you have to do a slightly different strategy, though they do have some overlap. So if you have an easy one, I have a whole video that goes over this, but the big picture on these is you find one rate law when one thing's held constant. Like for example, if this is held constant, it doesn't really matter what the number is. If you've doubled up one of these concentrations, it should double up the rate. If this is a first order, right? So if you've doubled this up and doubled that up, you can say, oh, it's a first order. If I've doubled this up and that's now times 4, it's a second order, right? Or if you double this up and it doesn't change the rate, it's a zero order in that regard. So you can kind of work through it nice and neat when you have the two held constant, and it's just a matter of saying, hey, if I double this, what happens to that? So those aren't too bad because you just kind of think through the math and you can see in this case that this, when you double this, you double that. So it's a first order there. But when you double this, this stays constant. So it's a zero order in that regard. So if you were to write the rate law for this easy one, up to the zero order, up to the first order, and you get that by comparing when something's held constant. The challenge is you can kind of do that for the first part for this one. Like you can see that the CO2 is held constant, so it doesn't really matter what that is if we're comparing trials 1 and 2. Um, and so you can see pretty clearly, without even us having to do any real math, that if I double this concentration, I double that rate. So I actually didn't even write out the math to prove this. I just know this is a first order in regard to that. So that's pretty easy for that part. But then the problem here is that, yeah, sure, this is almost doubled. And this is almost doubled. But then this has actually gone down. So that's going to contribute to our overall rate as well. So we can't do a simple comparison between these two because this is also changing. What we need to do is we need to use k because we still have the same little k constant, and kind of like how we were thinking about this earlier comparing the different rates, what you can do is you can think like, okay, I've got my rate at trial 2, I've got my rate at trial 3, and I can write those out, rate k, and then the reactant and its order, reactant and its order, so on and so forth. So we can generalize that, right? And this is the same little k constant because it is the same reaction, so they should be equal to each other. And you can think about this like, okay, if I've rearranged my rate law, I've now got my rate, my concentrations down here, you can make those two things equivalent. And that's basically how you figure out what exponent needs to go on here. So if you say, okay, well, I've got these two things that are constant, and I kind of worked through the math here. Um, it, it is kind of weird, and I honestly just kind of plugged in and checked. So if I plugged in 1 as my exponent, 1 in there, and I solve for this, these two sides do come out as equal. So that was just honestly a little bit of guess check. That's one way to do it. You can also kind of simplify these or combine these numbers but it can be a little bit tricky for people. So honestly, I would just set these two things up equal and then just plug in and check. The reason is that this is in the denominator. And so if you want to combine this number and that number, you can take 1.25 and divide it by 4.42, and that gives you 0.25. That's 0.25 kind of in the numerator, and this is still in the denominator. So you can do that here. And likewise, when I combine these two numbers, I get 0.67, and then this was still in the denominator. So that's one way to do it. If you don't like the math and how that worked out in that situation, what you can do, what makes it a little bit easier if you just kind of flip the two things that are equal, like instead of saying like this is equal to that, you can just flip the numerators and the denominators, which is kind of what I did over here. And that just puts it in a slightly more familiar like format to you where you've got this in the numerator. And then you can combine this and that, you get that number. You can combine this and that, you get that number. And likewise, it's just a matter of guess and check and plugging in numbers and seeing what makes the two sides equal. Because our little k should be equal between these different trials. That's essentially what we're saying is being held equal. And then through that, we're able to relate these different concentrations and their different rates and ask ourselves, well, yeah, sure, maybe this has decreased by like a third. The rate hasn't decreased by a third, it's increased. So now we can think about how much that's contributed and changed things if you do the math like that. Okay. So that's the main idea on these guys. You're equating them through those little k's and trying to then kind of plug in the exponent on that other one that is not easy. They'll usually give you one that is held constant so you can get that the exponent in the rate law, so you can know what order you are for that chemical. And then the second one, you have to do a little bit more complicated math. These problems will also ask you to rewrite the original rate law. So if you look, we've got our first order from the first part in light blue, right? That was what determined that when it was held constant. Now it was pretty easy. But for the second one, we had to do that complicated math. So we've got our orders here. What they typically will then do is say, like, pick any trial. It could be 1, 2, or 3, and you plug in the numbers. But it has to be like the numbers all from one of the trials. So if I pick trial 2 and we plug in the rate value that we saw and the concentrations that we started with, you can actually solve for little k. And so you can solve for little k, plug that in, and then also do that for the other trials and compare if you get the same value. And if you do, well, we now know the little k for the reaction, right? Okay, thanks for joining me. That's it. Thank you for McLearning with me. I've got a few more offers that I'd like to let you know about. And remember, like and subscribe. For each video on YouTube, I am making an interactive version using HP5. These will be for sale on Podia. And if you click on the link in the video, you should be able to go directly to that product. I also have 2 demos I'm going to be linking so you can kind of see what these products look like. So I would recommend checking out those demos. I also offer one-on-one remote tutoring through Wyzant. Please use the links that I have linked below. That way I can get 100% of the hourly rate as opposed to 75. Each video also has a link for my Patreon, and you can join at the $3 level to get some resources I use for tutoring or to support the channel. And I also have a $5 raffle level, which you could either get some free online tutoring or 5 interactive lessons for free. You choose which ones. And then I also have my Teachers Pay Teachers, which has some old lessons that I made from when I used to be a teacher. I may be adding to that. Thank you for spending your time with me. I hope that you learned something.